Hello everyone. In this video, I am going to do a simulation for a PIR sensor using an ARDUINO board. The PIR sensor is a passive infrared sensor that is an electronic device that detects motion by measuring changes. If a motion is there detected, then the LCD will print in. I am using an LCD liquid crystal display. That LCD will display a movement is detected. Using a visitor number. Using visitor number, we can using a variable visitor number. Using that variable, we can detect that motion is detected or not. Working principle of the infrared detection sensor is PIR sensor has two or more pyroelectric elements that detect infrared radiation. If using this infrared radiation, we can use do some automatic open and door close, door closing open. If a human is entering into the door, after some reaching some distance, using this PIR sensor, we can automatically open the door. This is the working principle of this PIR sensor. Signal processing, when the sensor process these changes and sends a digital signal that is high or low, indicating whether motion has been detected or not. The output is typically high when the motion is detected and low if no motion is detected. This detection range is usually between 5 to 12 meters we can detect. Applications we can use it in security alarms, motion activated cameras, and many of them. So we are going to setting up the PIR sensor in Proteus, passive infrared sensor in Proteus, and I will show a code for the I will show the code which I have written for this PIR sensor. Wait a minute. Yeah, this is the code I have written for this PIR sensor. First line is include liquid crystal.h. This is a library inclusion. This includes the library liquid crystal which provides function to control the character LCDs. That is, we are using a LCD. So liquid crystal LCD 13, 12, 11, 10, 9, 8. This means the initialization. LCD I am initializing with the pins called 13, 12, 11, 10, 9, 8. These pins should be connected to the ARDUINO board. And I am defining a PIR sensor 14. This means that the pin defines the PIR sensor as an pin 14 as an output pin. Then I am defining M11, M12, 0 and 1. This means M11 is defined as pin 0, likely controlling one aspect of the gate, and M12 is defined as a pin 1, that is another aspect of the gate. Int num, and then I am int num visitor, that is a global variable. This int num visitor, this will store the value, and this declares an integer variable num visitor to count the number of visitors. Yeah, if we are changing the detection motion detection, then the num visitor is getting changed. Then I am displaying a void setup function. This void setup function, here we are first we are initializing the num visitor is to 0. Then the LCD begin 20, 4. That is, LCD set to 20 columns and 4 rows in and it is cleared for display. And the M11 as output, M12 as output. Using this pin mode function, I am using setting the M11 and M12 as an output mode, and pin mode PIR sensor input. This means that PIR sensor pin is configured as an input pin, and the LCD displays visitor number and the initial visitor count. LCD will print visitor number. This program will process for 1 second delay I am giving, and then we are entering into the loop function. This loop function runs continuously after the setup function. Here we are going to detect the movement detection. That is, this checks if the PIR sensor detects motions. If it does, thus the following code executes. If we are reading this value from the PIR sensor using digital read function, if the motion is detected, then this if part of the code will get executed till this the if block of the code will get executed. So we'll go line by line. That the if the PIR sensor is detected the motion, then the num visitor is getting incremented to 1. So one visitor is getting entered into this mode. So then after incrementing the visitor count, there exists a display visitor count. The cursor is moved to the second row of the LCD to update the displayed visitor count. Then LCD set cursor and LCD gate opened, movement detected. Then after this display messages came, then display gate status. This is the gate status. I am going to display the gate status. This sets the cursor to the fourth row and displays that the gate is opened. And then I am going to digital write M11 high, M12 low, and after a delay of 1000, that is 1 millisecond, gate stop. This stops the gate by setting M11 to low and keeps M12 to low. Though this line I am telling for this line. And then after LCD cursor 0 set cursor LCD 03 and gate closed message will print. Then I am setting a digital write M11 as low and M12 as high. That indicates that the M11 to low means M12 to high means the close the gate, and with a 1 second delay. And simultaneously for digital write M11, 2 gates are getting closed, else this part will get executed. No movement detected means this part will get executed. That is the no movement message will print, and the gate will be in closed position. So now we will compile this program. ARDUINO. After compiling, you copy the hexadecimal file from the path and dump it into the ARDUINO board. Now it's getting compiled. After compiled, extract the hexadecimal file. Here you can find the hexadecimal file. Copy the hexadecimal file over here, and we will go into the simulation part. So this is the simple simulation I have done for the PIR sensor. So now we are going to dump the code into here. Yeah, we will dump the code. This is the PIR sensor. I have connected to the logic state to the test pin, and the ground to the ground, and output pin to the analog 0 pin, as I mentioned there. And I am connecting the LCD pins 13, 12, 11, 10, 9, 8, and I am using a motor to detect the movement. If there is any movement detection, then the motor will rotate and insist to the sensors. Now I am going to run the simulation. Yeah, now the visitor number is 0. As I initialize first it is 0. Now I am going to change this logic state value. So after now I am changing this value to 1. There will be a movement detected now. The motor is getting rotated, and there will be a movement detection. Yeah, movement detected, gate open. Now this gate rotated, you can see. Then again if I change it over here, the gate will get closing here. It's rotating. The gate is getting closed. Visitor number will change it as 1. Visitor number is getting incremented, and the movement is getting detected, and the gate is getting open. Now again I am going to change the value. The motor is getting rotated. Simultaneously the visitor number also should change. The movement detected and gate closed should be changed. This is the simulation I have done for the PIR sensor. Thank you.